Hello, and today I would like to talk about a few different methods for getting your bounding box. So here I have a rubber toy, which I translated, rotated, and changed the scale of it. So the most familiar one will be the bounding box. So the the bound node or the SOP bound, essentially just creates a geometry that represents your bound. As you can see, it's a actual geometry, and you can also change the padding, upper and so on. So you can do all sorts of adjustments here, like so. You can also generate different types of bounding types, but generally speaking, I think all of these stuff here are self-explanatory and you can experiment with them. So the next one will be the attribute promote, and most of the other ones actually do the same thing as a attribute promote does. So attribute promote promote. The attribute promote doesn't directly give you the bounding box back, but what it does, it can give you the, for example, the position. Let's promote this to detail, and this can give us the maximum. So it will give us, for example, the point somewhere here. We can also calculate the minimum, as you can see, and we get a point down here. Based off those two values, you can actually calculate the bounding box if you wanted to do it that way. But all the other actually functions, for example, get Bbox Min, does the same thing. So I'll get into the wrangle. So if I get the v, it's a vector, min, we can get Bbox. Get Bbox min. We can do a first input, and that's everything essentially. If I visualize this, then run this on detail, we can see that I'm running this on the minimum values, and we get the same result. So essentially what this does, it takes the minimum value of all of the points, or the same applies for max. Again, the same thing. And the similar thing applies in the VOP here, where in the VOP attribute VOP, let me delete these ones here so it's not as messy. We can again get the bound. So the bounding box, we want the first file, and we get a minimum and a maximum, the same thing that we get from the wrangle. If I visualize it here, I'll set this to the wrangle first. I'm creating two different points, which you can see I'm retrieving the details attribute here. This determines the input, so the first input, the name of the detail attribute min and max, and this is the index. So this is the first component of the vector, second component of the vector, third, and so on. So as you can see, we get points on the maximum and on the minimum values. This way you can, for example, take the detail here and add that to the x value, and you can move and create an additional point here. So this way, with those 2 points, you can actually mathematically calculate the bounding box if you need that. But I think the bound SOP could do that. You could do that with the bound SOP much more easily. Additional thing, if I switch the inputs, nothing changes because, again, this exports the same value. But there's another interesting thing, which doesn't necessarily give you the bounding box, but in here you can get the relative to bounding box, which if I plug this to my first input and the position, this retrieves a bounding box that will have values of 0 here, for example, and values of 1 here. So they're not actually like realistic position values, but they're normalized, if that makes sense. So for example, if I create, or if I do a vector to float, and I'll export this into the visualize this. Actually, let me also delete the delete attributes. Delete all of them in here, so we can just purely see this. And also visualize the color. So we can see that we have values ranging from 0 to 1 in the X, also in the Y, and also in the Z. So the relative bounding box is very handy when you're trying to, let's say, create some masks, because it already exports a normalized value. So you don't need to determine the max and minimums. Of course, there's a downside if you have, for example, an animated object and you want to keep, for example, you create a line here. So let's say, let me rearrange this. Let me, for example, create this fall off here. But let's say our rubber toy is animated or deforms. The line will move. So in this case, the relative bounding box is not that handy because the ranges will change. So I hope you learned something new and you can access this project file. And I'll see you again. Bye.